Hi, everybody. We're going to talk some now about statistical inference. And this is sort of the foundation for all the statistical analysis that we're going to do in quantitative research. So most of this should be a little bit of a review for you, but I'm assuming that maybe not all of you have looked at it recently. So let's just move on. Statistical inference allows us to estimate a population's characteristics from a sample that we draw from that population. So we're able to make assumptions about how well the sample represents the larger population. And then based upon probability and sampling error, we can draw some conclusions. So probability is the likelihood that any one event will occur given all the possible outcomes, and that's expressed as a p-value. The sampling error is the difference between the sample we draw from that population and the population as a whole. And repeated sample means form a normal distribution. And the standard error of the mean is equivalent to the population standard deviation. So remember back to our normal distribution curve, and probability is applied to that distribution. So you have a range of values and you have the distribution of the values, and then you estimate the values for the rest of the population based upon the observations in your sample. And if your sample is representative of the population, then you have a pretty good estimate. So let's review just a few other terms. You can see the median. You remember, median refers to the middle. So that's the middle of your range, the ones that are smack dab in the middle, half or below, half or above. The mode is the most common. So you can see the mode is at the peak of our curve here. The mode is the most common measure. The mean is the average. And so when you have some outliers over here that are a little higher, that makes your mean a little bit to the right of the peak of the curve. And those are just the concepts and terminology that you need to keep in mind. Confidence intervals are another thing that are going to help you make meaning of the analysis that you're either conducting or from the studies that you're reading. And it's an estimate of the population parameters. So there's a point estimate, which is a single value obtained from a sample, and the sample mean to the estimate mean, or mu, is the estimated population mean. And then interval estimate specifies the interval within which we believe the population parameters will lie. So the confidence interval is the range of scores that should contain the population mean. And it's plus or minus the standard deviation z-score. So confidence intervals with small sample sizes use a t-distribution, and those are samples less than 30. And if you're using a small sample size, you use the degrees of freedom, which is the sample minus 1, if you have 2 groups. You use that to calculate your confidence intervals for the t-distribution. So hypothesis testing, remember that we said a lot of statistics is really based on this double negative. So hypothesis testing starts with your null hypothesis. And the symbol for null hypothesis is a capital H and a 0 subscript. And that equals null hypothesis. And that means there is no difference between the treatment and control groups. And usually we want to see a difference. So our goal is to reject the null hypothesis. If we retain the null hypothesis, it means there's no difference between these groups. Now, capital H subscript 1 refers to the alternative hypothesis. And that is, there is a difference between our treatment and control group. And we can assume then that the difference is too large to be considered a result of chance alone. This is a statistically significant difference. Then you may see a directional hypothesis, and that's when your alternative hypothesis is stated as the mean of the population of A is greater than the mean of the population B. And that symbol is referred to as mu. And that's a directional hypothesis, and you only use that if you have very strong evidence to suggest that that's going to be the case. Usually you state them as we've stated them above. So what are the errors in hypothesis testing? If we reject the null, we conclude that the differences observed between the two groups were not to chance alone. So you can have a type 1 error and you can have a type 2 error. And that's if you make the wrong conclusions. And so the first one, let's talk about type 1 error, which is in our top box there. If we reject the null and we decide there's a difference between these two groups, when in reality there is not a difference between the mean of the two groups, we've committed a type 1 error, and that's represented by your alpha. The catacorner down from that is the type 2 error, which is referred to as beta. And that is when we do not reject the null and the null is false. So you can make errors in both categories, drawing the wrong conclusions two different ways. So we refer to those as type 1 and type 2 error. And just to summarize, a type 1 error is rejecting a true null hypothesis. So your alpha is set at 0.05, which means you have a 95% chance of rejecting or accepting a true null hypothesis. And that's your level of significance. So a type 1 error is when you reject a true null hypothesis. You conclude there is, you conclude that there is a difference between these two groups when the differences you're seeing are really by chance. And lowering your significance reduces the chance of type 1 error. So type 2 is retaining a false null hypothesis. So that's reflected as a beta, and usually the standard is a 0.2 with a power of 0.8, and decreasing the beta increases your power. So let's say a little bit more about statistical power. There's variance of the data, and the power increase with decrease variance. So if you have a sample and they all have similar findings, you have decreased variance and you have increased power. You also can increase power with a larger sample size. And then significance plays into this. As the chance of type 1 error increases, the chance of type 2 error decreases. And then the effect size, which is the magnitude of differences observed, also feeds into the power. So when you're reading and critiquing these articles or planning your own study, you want to conduct a power analysis, and you want to estimate the sample size you need to draw the right conclusions. And you want to determine the probability of type 2 error. So the statistical testing process then is to calculate a test statistic or a test ratio, and your Z ratio uses standard deviation units, and your Z score represents the distance between the observed score and the sample mean. And that's the critical region. It's the area above and below the Z equals plus or minus 1.96. So it's that 5%, 2.5 on both sides of your normal distribution curve. Now remember, we've talked about you can have a one-tailed or a two-tailed. You use a two-tailed when you have a null hypothesis that says there's no difference, and an alternative that says there is a difference. The one-tailed is when you say A is greater than B, and then you put all 5% on one end. But again, we only do that if we have extremely good data to support that. So once again, the degrees of freedom are calculated by your sample size minus 1, and the statistics are used to estimate the population parameters. So for parametric versus non-parametric, where parametric assumptions are that you have a random sample, there's a normal distribution, and goodness of fit to determine that normal distribution, and then there's homogeneity of the variance, or it's a homogeneous sample. So if any of those things are not true, then you want to use a non-parametric test. And we'll talk about both parametric and non-parametric as we move through the course. So now you kind of have a refresher and the foundations for the approach to statistical analysis. And I like this diagram because it sort of summarizes what we've been talking about. So you have a population of interest. You pull a sample from that population. From that sample, you test your hypotheses. You come up with your conclusion based on that sample, and then it goes back to the population, that this is the conclusion you're drawing about the population. So now we'll conclude this little presentation on inference, and you're ready to move on to the next.